Gino, you know why you're here?
Yeah, I know why you put me here, Vinny. Because you don't like Gino Scatterplopinelli running around using alternative stats techniques on your data.
That's about right. I had a sit down with Fisher and Tukey. We had considered talking to the Don.
You mean student?
Yeah, you know who I mean.
Oh man, that's not good. Could have led to a type 2 error. I can't believe this, Vinny.
Yeah, well, that's the position you put us in. Not good. So, anyway, tough guy, explain to me exactly why you thought it was a good idea to mess around with my data without even getting the go ahead from the higher ups.
Look, Vinny, I never meant to cause no trouble, you know? You did an analysis of variance in ANOVA, looking at the relationship between the transpiration of tree seedlings and a whole bunch of other variables. This analyzed the differences amongst group means. In ANOVA, to observe variance in a particular variable is partitioned into components attributable to different sources of variation over there. In its simplest form, ANOVA provides a statistical test of whether or not the means of several groups are equal, and therefore generalizes the t-test to more than two groups.
Yeah, stupid. And the t-test was developed by student, the Dawn. How could you go against the family? You know what happens when you go against a family, Gino.
Just listen, Vinny, I swear I meant nothing by it. The ANOVA is useful for comparing three or more means of groups of variables for statistical significance. It is conceptually similar to multiple two-sample t-tests, but is more conservative and therefore suited to a wide range of practical problems over there.
Exactly, you moron. Suited to a wide range of practical problems, like the practical problems you were about to have walking after I shatter your kneecaps, you dirty gabagool.
Oh man, Vinny, don't say that. Just listen, please. I'm telling you, there's a good reason. I wanted to just look at two variables, Vinny, not the whole lasagna. I figured I could just examine transpiration of tree seedlings versus the species of tree seedlings using a Mann-Whitney test.
So you went directly against orders from the Dawn.
Look, Vinny, I'm telling you, the Dawn never mentioned this specifically. Mann-Whitney is a non-parametric test of the null hypothesis over there. It says basically that it is equally likely that a randomly selected value from one sample will be less than or greater than a randomly selected value from a second sample. Since I was just checking two things, I figured it was okay, you know? Also, unlike the t-test, it does not require the assumption of normal distributions. Plus, as an added bonus, it is nearly as efficient as the t-test on normal distributions. All I wanted to do, Vinny, was check whether, without assuming the data to have a normal distribution at the 0.05 significant level, if the transpiration rate of all combined seedlings have identical data distribution. I was trying to help, see?
No, I don't, you mook. And ANOVA had already told us what we needed to know, that there was no significance of transpiration rates among tree species.
Look, I know, Vinny, I know, but I just thought if we looked at it a different way and found something there, maybe the dog would be pleased. All I did was a simple test. I changed all species to either Okapine to make two groups in order to meet the rules for the test. Then I just ran it in R.
Ah, seriously, Gino? You know we only use SAS around here, right? I ought to fit you for a pair of cement shoes just for that.
Oh, come on, Vinny. R is what everyone uses now. I know the old timers like SAS, but come on, you gotta see the future. Pass me the laptop and I'll show you. Now just look, Vinny, look. I'm just gonna show you this really quick, alright? I don't want you to get too mad over there.
You better hurry up, you piece of crap. I'm tired of looking at your face, and I'm tired of listening to your whiny little voice.
Well, look, all you gotta do is you start out here, right? And you load up your data. So here we go. We're gonna hit a little control enter action. And you can see there, we've got some things going on. I don't really like the name of that species column. It looks pretty stupid.
Yeah, stupid like your face. You dumb, stupid face.
All right, Vinny, that's enough. Just calm down. Now check it out. There we go. Now that name looks a lot better. Now we want to make all of these factors, right? So we're going to do that too. And then look at the structure. Look at that. That's like a fine panache. It's like a beautiful homemade ravioli melting in your mouth, tasting so good.
Now, normally you'd come over here and you'd run this linear model, right? And then you'd run an ANOVA. Yeah, so what of it? This is turning out worse than the pasta at Olive Garden. Hey, look, don't insult me. I'm trying here. I'm trying to just show you, Vinny. Just give me a minute. So instead of running this linear model and then the ANOVA, which you told me gave you no significance, was that how you put it? Yeah, I sure did, you dummy. Instead of doing that, you just take this Wilcox dot test, right? And then you run it for transpiration versus species. So let's do that, see what happens. Look at that. Look at that, smart guy. You thought you were so freaking smart, and instead you got an error. The grouping factor must have exactly 2 levels, like the 1-2 punch I'm about to give the side of your head. Just hold on, Vinny. Let me show you. This is normal. This is normal. So we're going to come over here. We're going to see why. Why did that happen? Well, look at that. There's more than 2 levels over here in the species column if you check carefully, which I obviously did. So I came over here and I made a new Excel file, and it's got only 2 species. See there? Good stuff. All right, so what are we going to do? We're going to come over here to Manwit, do a little Control-C for collagenol. Like I said, a little Control-C, then you come over here, and you're going to give it a little Control-V for Vinny. That's funny. Yeah, that's so funny I forgot to laugh, you stupid moron. Anyway, then you go through the same thing. You go through this, you hit your Control-Enter. Yup, we're looking good so far. Got a lot of factors with a proper species name. Now let's try the Wilcox test. Hey, and bada bing, bada boom. Look at that, Vinny. Roaringly significant.
You see what I did? Do you know what I found?
A one-way ticket to a shallow grave in Queens?
I found that at the .05 significance level, the transpiration rate data of oak and pine seedlings are non-identical populations. The null hypothesis was that transpiration rate data of oak and pine seedlings are identical populations. And you had found...
No significance.
Exactly, Vinny. Think about it. This could really mean something.
Yeah, it means you went against the family, using non-parametric analysis of my data to try and prove something to the student. I don't think I can even give you over to the Don. You're going directly to Zobolini.
Not Zobolini, Vinny. He's crazy. You know how many guys he's whacked?
I'm sorry, Gino. You went too far this time. They ain't gonna call you Scatterplot no more. It's gonna be Scatterbrains after Zobolini is done with you. See you in hell, Gino.